Okay, so I already did this video once, but it didn't record. So, and I don't have much time and I want to get it uploaded before class. You can pause the videos, take more time. I'm just going to do them quickly. All right, I'm sketching. Quadratic, all of these are y equal statements. So cup shape up, I can see that immediately. I know I'm on the increasing side for my y-intercept, but to prove it, we'll do minus b over 2a, which in this case is minus 20. You can see that, yes? Divided by 4, 2 times 2 is 4. So that's minus 5. And yes, 0 is bigger than minus 5. It's to the right. Okay, so now I already know that if I put a 0 in from this equation, I can see minus 3 pretty easily. 0, 0, minus 3. We'll do that each and every time. So the issue is, what do I get for a y value when I drop in a minus 5? Minus 5 times squared times 2 is 50. My next number better be minus 100 or it's not the correct number. Minus 5 times 20. It is correct. And then I still have minus 3. When you put the first two together, you get half the middle term. Minus 50 minus 3 is minus 53. Two checks. Next problem. I don't have my science card. Can I see this one? Yeah, it's a little left. I can bring this back. Square it up a little better. All right, that'll have to do. All right, I see a minus multiplier times x squared. That's cup shaped down. I'm on the increasing side. My y-intercept is going to be here. We've seen y numerically, but I'm sure I'll have to show it again. So I need the vertex minus b over 2a, which in this case is equal to minus 12 over 2 times negative 2, and that's equal to 3. That makes sense because 11, 0 is to the left of 3. And so now I know 0, 7 is my y-intercept. I got to plug a 3 in. Let's do that right above it. Middle term is 3 times 12, which is 36. This had better be negative 18. Oh, 3 squared is 9 times negative 2. Correct number. Plus 7. Half of 36 is 18 plus 7 gets me 25. Gets me 2 checks on the next test. Oops. Covered up the lens. All right, so y equals cup shape up. I'm on the decreasing side. That is the left side as I follow from left to right. I know that's going to be where my y-intercept is, but let's find out if it's true. 30 divided by 6 is 5. Yes, 0 is to the left of 5. And so 0 gets me 4. I just got to find out what gets me 5. So I drop it in. That's minus 150. Cut in half is minus 75 plus 4 is minus 71. Of course, it's useful to maybe put a 5 in here, which is 75. Oh, yeah, 75 minus 150. Yep, seems to be a pattern there. Okay, you're taking more time. Let me get this test here. And we've got 2 more quadratics to graph. What's it take? Vertex and another point. Of course, I think it'd probably be wise if you did 3 points. Let's do 3 points on this one. Okie dokie. So, cup shape down. I'm on the increasing side for the y-intercept. That finger goes up, then down. I'm on the increasing side. So therefore, I got to find the vertex. So minus b over 2 times negative 3, negative 6. Looks like 2. Yes, 0 is to the left of 2, and I get a negative 5 if I put a 0 into the original. What do I get if I put a 2 in? Minus 12. Better be 24. Oh, it is. Minus 5, so that gets me 12 minus 5, which I guess gets me 7. Yep. And of course, we know the roots, don't we? The roots here are 0. That was from another video. So I'm measuring from 2, plus or minus. The roots are real. 7/3. Boy. Yep, there's the positive one, there's the negative one. Yep, but it is also nice if you knew 0, 2, or 4 should get us negative 5 as well. You can always put a 4 through and show that it's negative 5. All right, 2x squared plus 7 is really in graphing form already. All right, you always want to make a 0 out of the squaring process. That's what we're really doing, but not showing the graphing form. So therefore, this is cup shape up, 0, 7. And another point is needed to make sure that this is a unique graph. I'll throw a 5 in. Let's see if I can figure out. So from 0 to 5 is 5 units of change, which means if I square it, it's 25. But if I double it, it's 50. I should get 57. Let's see if we do. 5 minus 0, 5 squared, 25 times 2, 57. Yeah, so how do you get from 7 to 57? Looks like you got to go up 50. That's what I was doing. And of course, from 0 to 5 is linear. But we want quadratic change, which is 25. Yep. If I went over 5, I should have gone up 25. I really went up 50. Looks like it's doubling the squaring process. All right, now we're doing absolute value, which I have to bring it down to this classroom. All right, absolute value is a V shape. Here's the absolute value of y equals x. What's absolute value do? Changes those negative y values into positive, and we get a V-shaped graph. This measures change from 4. Distance from 4 on a number line. Here's 4. What's the shortest distance I can travel? 0. Okay, so that tells me that if I put a 4 in, V-shape up, positive. If I put a 4 in, the first term becomes 0, and I'm left with a 5. And it's nice to have the y-intercept. So let's get a 0 here, which is to the left of 4. I get absolute value of negative 4 is 4, times 2 is 8, plus 5 is 13, which means that if I put an 8 in, I should also get 13. 8 minus 4, 4. How far is 8 from 4? 4 units, times 2, 8, plus 5, 13. Next problem. Well, we can already see it. V-shape down, because that's negative. Negative 6 gets me negative 7. I'll throw a 0 in, which is to the right of negative 6. If I put a 0 in, I get minus 12, minus 7, minus 19. And I think the slope is going to be negative 2 on this side and positive 2 on that side. Because over here, negative 12 should get me negative 19. How do you get from negative 12 to negative 6? You change by 6 in the x. Negative 19 to negative 7, you go up by 12. Over here, how do you get from negative 7 to negative 19? You go down 12. And how do you get from negative 6 to 0? You go up 6. So on the left, you're going up 2 to 1, over 1 up 2, and on the right, over 1 down 2. That's going to become important in later classes when we start writing these as piecewise functions. All right, we got 2 more of these to do. And this is recording finally. I see a positive, I see a V-shape up, I see an 8 and a 9. Zeros to the left. If I put a 0 in, 24 plus 9, 33. And that should happen if I put a 16 in as well. I still get 8 times 3, 24 plus 9, 33. Okay, it's a 10-second question if you know what you're doing. Next one, last one. Nope, not the last one. I got a negative absolute value. Absolute value, a V shape, absolute value. Cup, V shape down, 50, 60. And that means if I go over 1, I should go down 3 on this side, which means that a 51 should give me 57. And you can plug it in to see if that's true. I can see that it is true. But we want the y-intercept. So I'm going to put a 0 in, not drawn to scale now. It's not drawn to scale. So it's probably, y-intercept's probably a lot further down than what I'm labeling. So I'll get rid of that, pretend I don't see it. So that's 50 minus 150 plus 60 is minus 90. 0, negative 90. All right, and the last one, 2 times the absolute value of x plus 11. We want that to be 0. I think it's pretty easy to see that 0 gets us 11, and that's the shortest distance you can travel from 0 is 0. Okay? So I got to find something else. Why don't we pick a 5 here? That gets me 21. How far is it from 11 to 21? 10 units, 0 to 5, 5 units. Sure looks like a slope of 2 to 1 to me. Make a connection there. All right, now we're moving to sketching square root. And keep in mind that square roots have a minimum. Square roots have a minimum. All right, here's a square. That's a square root. I can make it smaller. There's a square root. The smallest I can make it is 0. Because 0 times 0 equals 0. Then the square root of 0 is one of those factors. And if you look at the square root process, square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, square root of 9 is 3, square root of 16 is 4. I'm going up by 1 with user-friendly numbers, but each width is bigger than the previous one. So it's got a concave down shape, because I'm going up very quickly at the start. That's fractional. I'm not going to get into that right now. But eventually, right, a bigger and bigger square moves me up 1. You can look at the table. 2, 4, 3, 9, 4, 16. Square roots go from the area back, right? Bigger horizontal than vertical. All right, so we want to make the square root. I like to make the square root 0, and I like to make it the square root of 25. But you can make it anything you want as long as it's easy to work with. So what makes a 0? 3. 3 gets us 4. 3 gets us 4. And I'm going to put in a 28. Easy to work with. 28 minus 3, 25. Square root of 25, 5 times 2, 10 plus 4, 14. All right, so if I started here, I do x minus 3 plus 4. From 4 to 14 is a jump of 10. And if I put 28 in, 28 minus 3 is the square root of 28 minus 3. I hope you can see that's 5 into 10. That's where this 2 is coming from. All right, so I think I'll make some space here now and work above it. We're looking at this one. Well, that's going to be downward trajectory. -5, -6. Big time pattern here. Drop in a 20. I get the square root of 25, which is 5, minus 10, minus 16. That works. Next, you pause the video, try to graph this. Slow growth. 3 times what I had to begin with, though. 20 gets you 70. Which means that the domain is x values greater than or equal to 20. That's all these x values are to the right of 20, but it could also equal 20. And all these y values, the range is greater than 70. All those y values are bigger than this one, except for that one. Okay. So I'm going to put in a 20. What do I want to put in here? Why don't I put in 29 just to show you it doesn't have to be my square root of 25. 29 minus 20 is square root of 9. Square root of 9 is 3 times 3 is 9 plus 70, 79. So I forgot what I put in. I think I put 29 in there. And that got me 79. Right? But this can be a random, that can be a different value. You could have made the square root of 100 if you wanted. Right? Anything that you don't need a calculator for. All right, one more here. So what makes a 0? This is a little harder. -4 gets me -10. And this critter is definitely going down. Okay, so I got to do 2x plus 8 equals some nice number. How about 16? Because that's going to get me the square root of 16 is 4, minus 12 minus 10 is -22. And I just got to put it somewhere. All right, so subtract 8, divide by 2. So I want the number 4. And that's going to get me -22. And the last one again, I could write x minus 0. It's not necessary, so we don't put it there. But what makes this square root 0? 0. It's going up, steeper, but eventually slows down considerably. Okay, so 0 gets you 7. And, you know, what do you want to pick? 9, 16, 25, 36. How about we pick 36? So 36 might be way out here. Who knows? Depending on the scale I'm using. So that's 36. And square root of 36 is 6 times 5 is 37. 36 gets you 37. You can find more points. Put yourself on some graph paper. You'll see the shape eventually materialize. What's the domain and range of this problem? Well, x's are greater than or equal to what? 0. Y's are greater than or equal to what? That's your range. All right, now we're going to do some exponential graphing. And all of these graph becomes 10 seconds or less once you learn what you're doing. It takes 10 seconds to graph these things. All right. So I got growth or decay. And that's determined by the base. So if you're doubling something, what are you doubling? 10. So I have 10 units. I double it, it's 20. If I cut it in half, it's 5. But we're going to do the 10 and the 20. And we're going to get a graph that looks like that. And that graph is based on some number. What number? Looks like it's based on y equals 5. So, looks like 1900s are easy number to work with. So 1900 minus 1900 makes 2 to the 0. 2 to the 0 is 1. 1 times 10 is 10 plus 5 is 15. 10 plus 5 is 15. And that's this coordinate. And you don't have to draw that, but you have to know that that's your first jump. Your second jump is 20. Your third jump is 40. So we can certainly find other points pretty easily. But let's find that one. Well, looks like 70 units. So 1970 looks friendly because that gets us an exponent of 1. And 2 to the 1 is 2 times 10 is 20 plus 5. 5 plus 20, 25, 1970. And you take the time to put these numbers into the equation so you can see what's happening. All right, that's that one. Again, I got to do this fast because I got to get it uploaded before class. So that's out of the way. All right, now we're looking at this one. I see 4. That's my asymptote. I see decay, something times a half. Those differentials will be a half. What's my first differential? 40. What's my second differential? Half of 40, 20. Well, that gets my y values pretty easily. 4 plus 40 is 44. And 4 plus 20 is 24. So the issue is, can I find the x values that get me zeros and ones for exponents? What gets me a 0? 2000. What gets me a 1? 24 units later. 2024. Oops, I hate the same number showing up. It did. Too bad. Next problem. I'm looking for the asymptote. 7. I could have put the 7 at the end. All right? It's the constant. So y equals 7. Growth or decay? Growth, tripling. Going up pretty steeply. What's my first jump? 5. What's my second jump? 15. 3 times that. Okay, so 7 and 5 make 12. That's that y value. Provided I make a 0, 2023. What's my jump in years? 30 years. That's 2053. 7 and 15, 22. You got to put some time and effort into this. Last one. Then I can upload this. And I got to be somewhere else in a moment. So now I can do it over here much easier. That's 10. Decay, a third of. My first jump is 60. That's 60. A third of 60 is 20. All right? 2 points. My first year is 1999. 1/3 to the 0 is 1. 1 jump of 60 and 10 makes 70. My next year is 20 years later, which is 2019. 20 plus 10 should get me 30. Let's throw 2019 in here. minus 1919 is 20. 20 divided by 20 is 1. 1/3 is 60 is 20. On top of 10 is 30. All right. Test tomorrow. I should have squared that up better, but I'm on the move.